Hello and welcome back to Ready Controls YouTube channel. If you're passionate about automation and control systems, you have come to the right place. In today's video, we're going to explore the limit instruction and the FFL, which is first in, first out load instruction in Studio 5000. We'll break down how these instructions work, explain the associated bits, and discuss their application in logging cycle time for conveyor PLC project we are working on. If you haven't seen the previous videos in the series, I'll be referencing them, and you should have pop up on the top right side of the video. So be sure to check them out through the playlist link in descriptions. So going back to last video, we calculated the total cycle time by using the compute instruction. While the compute instruction works, there is a better way to log it, better way to calculate the cycle time instead of a compute instruction. Say if you have 100 steps, then the compute instruction would be very cumbersome. So let's talk about how do we calculate total cycle time. So if you look at our logic, step 10 is when the product is on the, when step 10 is when the machine is in auto cycle start. So if the sequencer is in step 0, and once we do an auto cycle start, the sequencer moves into step 10. So ideally, any time between step 10 and all the way to 90 is the current cycle time, right? So what we can do is go ahead and insert a new rung here, and we will use we'll introduce a new instruction called limit. So if I hit insert on my key tab and we search for LIM, in the version before 36 the mnemonic for limit was LIM, but in version 36 it's limit now. So if you look at limit limit instruction is used to determine if a test value is within the limits, right? This is especially useful for validating data or triggering actions based on set thresholds. So the first operand is a low limit. The first operand is low limit. This sets the lower boundary of accepted range, right? For us, the lower limit is 10 because we know from step 10 is where we need to calculate the cycle time. And the high limit is the highest the sequencer can go is 90. So we got our low limit and high limits. Now the test parameter we're going to use, the test value we're going to use is the value called sequencer step, right? That's the step of the machine. So in order to make the simulation easy, I'm going to create a simulator bit which will simulate the sequence step. That way it's a lot easy for me to manipulate it and show you how the logic is working. So we'll create a new simulate signal and just simulate the sequence. So that's a sequence. So now we know if the machine is between 10 and 90, we want to calculate the time. So we'll go ahead and calculate the cycle time. We'll go ahead and insert on my keyboard, type RTO for retentive timer on. There is a separate video for RTOs that would I would mention up. The link should be showing up on the top right side for the timer section on this channel. So we call this as a total, just call it cycle time, current cycle time. I'll just say current cycle time, and we create a cycle time, current cycle time, and it's already created. I'm reusing it. It's 86400 seconds. 86,400 seconds is what we have in one day. I just used that number there. So now what this instruction is going to do is, if the test tag is between 10 and 90, the timer will start. Right now step value is this tag value is 0, so the timer doesn't time. And one thing with the limit is it's inclusive of the limits. That means if I make that 10, the timer stops, right? If I make the simulate signal 90, the timer is still starting. But the moment the value is outside of the zone, that means if it's 91, the instruction goes false and the timer does not start. If the value goes to 9, which is still outside of these limits, it won't stop, right? So this is how limit instruction works, right? If your lower limit is less than higher limit, that means any value from 10 all the way to 90 makes the timer start. Okay? Now if you flip it the opposite way, if you want to use the reverse way, we make 90 as low limit, high limit as 10, right? So what would happen now is it will work exactly opposite, right? Now, since whenever the low limit is greater than high limit, I make 11, it doesn't work. But if it is 91, then the timer starts. So anything outside of 10 and 90 will make the limit instruction true. So anything 100 will make it true. But the moment if it's in the range of 10 and 90, say if it's 50, then it stops. So for our application, we don't need to have this condition. We just use a straightforward condition where we know our low limit is 10, we know our high limit is 90, and that's when we want to calculate the cycle time. So that's all about the limit instruction. Okay. Now we have the limit instructions, right? Now we want to have a log of these limit instructions so we can just show what is the cycle time for the last 10 cycles. So for this we will introduce a new instruction called as FFL, which is the first in first out load instruction. Okay, so we'll go ahead and introduce that. We'll do insert on the keyboard, inserts a new line, and then hit insert FFL, which is FIFO Load. As you can see, FIFO Load has a source. This instruction has a source value. Make it bigger to see. So we have a source value, a FIFO control, length and position. We'll go, and then the outputs are enable, done and empty bits. So we'll go one at a time, right? So operand store is the source is the data you want to load into the first in first out queue. This could be a value from input, a calculated result that needs to be processed in a specific order. It can be an integer, bool, it could be even string, right? So what we will do here is, we know our source is, we want to log the cycle time. So our source will be current cycle time dot accumulated value of the time. And we want to load into, say we want to, one thing with the FIFOs, with the Rockwell's FIFO instruction is it says 0 index base. So whenever we reset, it will go back to 1. So if we want to track last 10 cycles, we need to make sure our FIFO is 11. FIFO size is 11. That means we can start at 1, go all the way to 10. 0 to 10 is 11 integers. So 11 array elements. So we'll call it current cycle time FIFO. Okay. And you create your FIFO, make sure the FIFO data type, the FIFO array data type is same as the source data type. So in here, the timer is of a timer accumulator value is of a data type dint, so we'll use dint. And since I want 10, I want to log 10, I will use 11 as my array size. Okay, so create a FIFO, and we create a time, and we just need to mention here the control. FIFO has its own control parameter, that's a structure tag that manages the overall operation of the FIFO instruction. It includes various bits and counters that we'll explore in detail in later videos. So we'll just create a control, we just call it cc time underscore FIFO underscore ctl, just a control. We hit new data type of type control, say okay. Length is we want 11, and position we start at 0. What this would do is, every time we want to log the cycle time into this FIFO, based on a trigger condition. The trigger condition for us is we use a equal to instruction. We know when our sequence step simulate is equal to 0, because in our logic the sequence step, whenever it's 0, that's when the machine resets the sequencer. So for keeping it the same, I'm just using this condition as a trigger. So every time the sequence step is equal to 0, we move the FIFO, we move the current cycle time snapshot of it, put it into the array element 0, right? And also we want to make sure whenever the FIFO is full, whenever the, right now see it's showing empty because there is nothing in the string. So let's look up the monitor, and you could see, put them side by side, we created 0 to 10, 11 arrays, 11 dint, an array of 11 dints here, okay. So, and the bits are empty, the controller, so it has length is 10, the control word has a dot length, attribute as 11, position is 0, enable, it's not enabled, it's not done, it's empty, there is no error, okay. So now what we want to do is also have a logic where when the done bit is high on this FIFO, we want to reset the FIFO. Just use a, okay, right? So now we'll go ahead and watch how this happens. So we are in step 50, so we'll make the simulate as 0. We reset the sequence, and whenever the simulate is 0, whatever the timer value of this time is logged into the cycle time, right? For demonstration, I'm making this simpler to show, but there would be logic required to reset whenever the sequence is 0. We want to reset the cycle time, so we'll go ahead and add reset for this cycle time. In the original logic, we already have a reset for the cycle time, so I didn't need to do that, but since we are simulating it with a simulation timer, we're going to use this instruction. Okay, so now I'll make the simulate to 20. The machine is running. We have a cycle time timing, index all the way to 90, and then we make it a 0. Now that time moved into array position 1, and also you could see the timer is reset because of this instruction. So I will just keep indexing this and reset it. Now we got 5 seconds. Now we'll start one more cycle, let it run for a while, and we say sequence is done by making that 0. Now we got the other time. As you can see, the position is 4, so it moved 0, 1, 2, 3. So when we say position is 4, the next value it's going to drop in is position 4, which is nothing but array element 4. And now it's ready for the next time. It will go into 5, 0, 20, 0. We are in step 7. We are in index position 7. And now we'll go ahead and do to 8, step position 8, position 9, position 10 now. So we filled up 0 to 10, 11. So we filled up 1 to 10. See how the sequencer reset to position 1 on the reset. That's why we want to make it 11, so it starts at 10. So that's how we log last 10 average, last 10 cycle times using a FIFO load instruction. To sum up, we used a limit instruction which helped us to do cycle time calculation. Since our machine is from 10 to 90, we use that as a lower limit as 10, high limit as 90, and we made the current cycle time, created a RTO, and we have a reset every time the sequencer step is equal to 0. That's when we log the current cycle time, and then we reset the cycle, reset the timer. And once the FIFO instruction is done, we're going to reset the control, which will make the position go back to 1. So that's how we use limits and FIFO loads to log the last 10 cycle times of the machine. If you have found this video helpful, please give it a thumbs up and consider subscribing to the channel for more in-depth tutorials. Thanks for watching. If you have any questions or need further clarification, drop a comment below. Don't forget to check out the playlist to catch up on previous videos, and I'll see you in the next video. Thank you.